science from the island of Carriacou off the coast of Grenada. 5 scientists have been taken away from their nice, clean laboratories and brought to a derelict lime factory where they have to adapt their science know-how to solve a series of challenges. This is about science. It's not about survival or competition. Cooperation and ingenuity are the keys to their success. With nothing more than their wits, some simple tools and the natural resources of the island, our team of scientists will have just 3 days to solve a series of mind-bending challenges. Will our intrepid scientists succeed? Find out next on Rough Science. Occasionally we all need to let off steam and party, and the scientists are no exception. But here at the lime factory, they're going to have to make their own fun. So can they use the science of celebration to make their bash go with a bang? What do you think about the idea of having a party?
Yeah!
Yep. It is going to be work, though, but I think it'd be fun. Can you guys do a firework display?
Yes!
Ooh, sparklers.
Yeah.
Catherine wheels.
Yeah. Rocket, big rockets. We want big rockets. Pyrotechnics. Light up the sky.
Yeah,
Yeah?
sparklers and things.
That would be absolutely brilliant.
We'll try.
Absolutely brilliant.
Yeah.
And then musical accompaniment from you three. It's got to be tuned. It's got to be lovely. No just bashing saucepans. That's
My parents will never watch that. That's it. They turned off. They know what I was like with the violin.
So some nice music to go with the fireworks. Yeah? Great.
What was-
Does that sound like
bring
a
it
good
all
idea?
together at the-
Bring it all together at the end. Have a big kind of, you know, celebration.
It won't be Sydney Harbour Bridge at Millennium.
Well, you
Eve.
know, as close as we can get.
Yeah,
I think
all
would be
right.
nice.
Yeah,
Yeah?
yeah.
Are we on for that?
try.
Brilliant. 3 days as usual. Starting now. Let's go.
All right.
I've never played a musical instrument in my life. How about you?
I like listening to nice sounds, but I've tried playing loads of musical instruments and
Yeah?
I'm universally rubbish.
But at least you know some of the theory behind making them sound
No,
nice.
not really.
No? How about you?
I play the violin most of the way through school.
They're fantastic.
Not very good, and I don't know how to read music.
So what kind of instrument should we make?
I'd love to make something out of strings, the whole plucking. I think that'd be hard, but really fun.
I like big music. I quite like church music, although I don't go to church. So, I don't know, maybe an organ or something.
And I think I need to start by making something that tunes everything for us.
Great.
So, I mean, I know enough to be able to, I think, make a column that will play middle C if we blow into it. And that can tune everything else.
Wow.
Crikey.
To make beautiful music, Kathy's trying to produce a pure note in a pipe to tune all their instruments too. She's applying her physics brain to try and work out the science of sound waves and vibrations. The maths of music.
I happen to know that the frequency of middle C is 256 vibrations per second. So even something like a drinking straw, there's a particular frequency that it will make a kind of noise at. So
Okay.
just hold them for a sec.
All right.
And you can hear that, right?
Yeah.
Oh.
Wow, that is incredible.
And that just shows that the length of the straw, the length
Yeah.
of the instrument usually, will determine what frequency you actually hear. Okay, and so that's all I'm doing. I'm finding a column of air that corresponds to the note that should be a middle C.
So there's actually a formula that says, you know, X length of pipe will give you middle C.
Yeah.
Kathy's being mathematical and Mike's being, well, Mike. He's going for a more experimental approach. He's going to need a lot of puff to blow into that pipe.
I wanted to make something big, and I quite like the sound of an organ. And I know that tubes are going to have their own resonant frequency, and if you set up vibrations within them, it'll work like a church organ. So, in order to make air rise, I just thought that a flame might set up some sort of updraft.
Sounds like he's planning to set the place on fire. Ellen's keeping out of the way. Her music's coming along with a botanical bent.
Those are the seeds of the calabash. They're really pretty seeds. They're heart-shaped. But it makes such a delicate sound. So, I'm going to get some shells and coral.
the party will go with a rattle, but what about a bang?
We've got a lot to do, haven't we?
We've got 3 days to make fireworks. I reckon I've drawn up this programme.
Yep.
Programme.
Okay.
On the first day, we've got to get the ingredients.
Right.
Potassium nitrate. I know where we can get that, I think. And some charcoal, or we can make that.
Yep.
And some sulphur, which we've been given.
Yeah, that's in the kit, isn't it?
That's in the kit. And some form of ignition device.
Yeah, it'd be nice not to have to actually go up to these things and light them, wouldn't it?
Yeah.
So if you have sort of remote operation,
Yeah.
something like a little filament that burns or something with electricity. Yeah, I'll sort out something with that.
Yeah, because we're going to be thinking about safety. We're going to be conscious of that all the time, haven't we?
Jonathan wants to keep his distance from the fireworks, so Mike B's in charge of making gunpowder. He's got sulphur. Charcoal's easy to make, but finding the other key ingredient, potassium nitrate, is a dirty job, and Mike's got to do it.
You're likely to find potassium nitrate wherever there's waste products like human excrement or goat droppings or bat droppings, because there are microorganisms in the soil which will react with the organic compounds in the manure, which will produce nitrates, and potassium nitrate is one of those.
I've been roped into sawing wood to make charcoal for the gunpowder.
Hello, Mikey B.
Hey, kitties.
What have you got in your bucket?
Bat droppings, soil, goat manure. I think this is going to be a source of potassium nitrate. So what I do is just add water to that and then boil it all up and get it hot. And then I'll add some wood ashes from the fire, and that'll boost the yield of potassium nitrate.
Oh, so it's another big distilling, filtering thing going on.
It is filtering,
Your favourite.
crystallising. Yeah.
All right, then. I'll
Bucket
better get on
comes.
with this sawing.
All right, baby.
Halfway through day one, and Mike's as happy as a chemist in goat poo. And Kathy is calculating. Her physicist's head is full of useful things like the speed of sound and the frequency of middle C. After fiddling around with those in her formula, she's got the solution to playing a pure note.
OK, this number here, 64.5 centimetres, that's the length of tube that's needed to produce a note that's middle C. And I've worked out all the other notes from that number just by using kind of simple ratios, and that gives the natural musical scale, the normal one that we're all used to hearing.
Kathy's confident about her theory, but what about Mike's experiment?
Right, if I slide this piece of wood with the candle under the pipe, hopefully it'll bring it close enough to make some sort of noise. And that's actually way better than I expected. That's quite
What are you doing?
This is a musical instrument.
Is it?
Yeah, well,
Like
it's
a
sort
hornet's
of...
nest.
I think it sounds sort of bassy, and
I suppose so.
I knew we wouldn't be able to make a pump,
Yeah.
so I just thought of other ways of getting air up there, and there's no way I was going to lay down blow, so it's gone out.
It has gone out. It's smoking furiously.
It's smoking furiously. But it worked for a while.
Well, so is the theory basically to have a row of these and with candles underneath each of them?
Yeah.
I hope it's going to work better than this.
I think it's going to work great.
This thing better not be anywhere near the fireworks, but that'll depend on Jonathan's detonation device. This looks absolutely fantastic. What is it?
Cartoon time.
It is. I feel like the coyote in Roadrunner.
And believe it or not, it's just a switch.
Right.
But it switches the power from the battery
Yeah.
to this little filament.
Yeah.
So when you do that,
Yeah.
all the power of the battery will go into here, which should make it go like a fuse. It will just go red hot.
Okay.
And that eventually will be in our fireworks so that we can electronically detonate them.
Can we give it a test then?
Yeah, I'll count you down.
All right.
3, 2, 1.
Wow! Well, it burnt.
Yeah, you see it go red hot, didn't you?
Yeah.
That'd be enough to set the gunpowder on fire,
So that's
what you want.
basically in the firework, and that just sets it off.
Yep.
And end of day one, and after a lot of huffing and puffing, they might have middle C, but no tuned instruments. And they've found goat poo, but there's no gunpowder yet, so no fireworks. Will our bash go with a bang? Early morning, our orchestra need instruments. Time to put theory into practice. Ellen's found a sound scientific use for a calabash.
What I'm making is an mbira, and that is a musical instrument. I know it's used a lot in ceremonies. It's used all the time in Zimbabwe. And the sound vibrations hit the air, and it makes it louder, and then it comes out because we have a hole. And so that's why instruments have resonators or sound boxes.
The strings are working quite well now, and we can change the tension nicely.
The tension on the hacksaw blades is important because, for example, this is no tension.
Amazing what you can achieve with a sound box and some tense metal. But I think it's time to pick a party piece to play. Group discussion! Oh, I love it when that happens. Right, this party. Don't you think we need to kind of work out what we're going to play?
Yeah.
Otherwise it's going to be a real mess. Anyone got any
Something that
ideas?
goes well with fireworks. It's got to be something fanfare-y.
Richard Strauss stuff from the 2001. The Sprack was the first
That would be fantastic.
It's like 6 notes or something. We can do that.
Do you think that would work with fireworks? A musical plan, but what about the gunpowder plot? Have the goat droppings delivered the final precious ingredient, potassium nitrate?
This is the filter paper we use to filter the solution containing what we think is a potassium nitrate. Now, you watch this. When I set fire to it... Look at that. And that tells me, I know it's a very unscientific test, but that tells me that's a pretty good indication there's potassium nitrate in there. So these are the 3 ingredients for the gunpowder. We've got charcoal, we've got sulphur, which we've been given, and we've got potassium nitrate crystals.
Mike B disappears off to work a bit of his chemical magic on the 3 ingredients to turn them into gunpowder. Time to test his results, and the detonator too.
Do we need these glasses? Yes, put your safety goggles on.
Okay.
I have sat in prime plunge position. I hope you noticed that. None of you are allowed to touch this, so this is my device now. Right.
Go on then.
Do I do it?
3, 2, 1.
Oh, that's brilliant!
This is even a time delay.
Is that just because of the length of wire it's going to
It
travel
takes
down?
a while to heat up the web.
What happens is that the potassium nitrate provides the oxygen for the charcoal and the sulphur, which are the fuel. Right? And you get massive quantities of carbon dioxide, carbon monoxide, nitrogen. So massive amount of gas produced from this small amount of solid. But what makes it even more exciting is that the reaction between the 3 components generates heat, so that expands the gases as well. So,
And that gives you your woof.
yeah.
Having the banger would be great, a big kind of woof, but it would be fantastic. I mean, do you think we could get a kind of a rocket, a big woof? How do we get that sort of whoosh effect?
In a bang or explosion, you've got a small container with all the gunpowder in that's giving off all these hot gases, and it just rips the container apart, which is the explosion. But if you have a container where one end is a little hole, and you have to make the hole the right size, obviously, it doesn't quite explode, but all this hot gases comes out the backside of it really fast.
Well, so it's like this big thrust coming out the back.
Yep. And Newton's law is every action there's an equal and opposite reaction. So when all this stuff is powering out one end, it's pushing the rocket at the other end. So basically a rocket is thrusting stuff down, and that thrust makes it go upwards.
Okay.
So the people who went to the moon were sitting on basically a massive bomb, but a very controlled bomb, which wasn't going to explode. It was just going to thrust all the stuff out. And so that's what we've got to do there. And I think it's going to need a lot of trial and error. I think some of them are going to blow up.
Well, I'm here to do lots of trial and
That's
lots
why
of
we've got
error.
a long string on the end.
Why, are you calling me dangerous?
No.
I've taken Kathy's middle C, open ended pipe, and I'm making pan pipes, and pan pipes are closed on one end. And that means that to make the same note, I have to cut the length in half. So this is a middle C, and so is this. And based on this middle C, we then made the other 4 notes that we're going to need. Now what I'm going to do is I'm going to tie these together, and then we will use these pan pipes, and especially middle C, to tune the rest of our instruments.
It sounds simple, but how on earth do you tune a thing like this?
All 3 of these should be C. It should be middle C, low C, and 1 octave below that. So these should all be playing C in 1 octave or another.
Here's my C.
None of these sound like that note, do they?
Do any of them sound like a C or any of the other notes when we actually hit them?
Let's put them out and see. They're going to be different notes, but...
You just pull them?
Yeah, and then blow very hard. Yeah. Like that. Right, okay, ready? That matches, doesn't it?
That's pretty good.
So the flame organ has turned into tubular bells. But what about our other bangers?
OK.
You all wired?
Yeah.
It's a banger, basically.
Yeah, basically, because it's all sealed. So when I put the plunger down, the wire should glow, which should set off the gunpowder, which should make a bang. Go on, then.
Can I do it?
Yeah.
You just...
And we're 30 or 40 foot away here, aren't we? So
Yeah.
we don't need the safety specs.
OK. So are we looking for noise rather than light?
Yeah, I mean, if the powder's fast enough, we should have a big bang.
OK.
If it isn't, it may just burn through the paper quicker than the gases can break through it.
Right.
In which case it would be
a bit of a damp squib.
A bit of a damp squib,
OK.
yes.
Count me down, Jonathan.
OK, 3, 2, 1... I know it's a lot of fun with all the fireworks and all the stuff we've been doing, but there is, like, a real serious point to be made because the chemical energy involved is incredibly dangerous and powerful.
Fortunately, Mike B seems to know what he's doing.
Mark 2 banger, fire on 3. 1, 2, 3.
That was pretty good.
That's an improvement, isn't it?
Are we going to go even bigger?
Let's go bigger. Jonathan! Mark 3 banger, fire on 3. 1,
2, 3.
Just a little suspense for you. Thought I put that one in.
there was shrapnel everywhere. It was terrible. On to Mark 4.
Mark 4!
Oh,
we want one that goes in the air!
Yes.
Woohoo!
Let's go.
End of day 2, and we've got bangs and twangs. But tomorrow we need an orchestra, 2001 music, and they promised me rockets.
We have all our instruments together here,
Right.
OK? And we just have to work out how to play them together to sound right.
That would be good.
Yeah?
That would be good. What have you actually got?
You've got the first 3 notes at least, haven't you, on that?
We've got a C, another C, and then we've got what we think is probably an A.
What are those? Because those 3 notes are the first 3 notes of our 2001 theme, aren't they? Are they not?
That's a shame because there's such a nice noise.
But Mike has a good, really loud C, and I have a really lousy C.
Should we see how it sounds? 'Cause it might be really bizarre.
The first note.
Well, should we see? It may be bizarre.
Ready?
That's for the second phrase of it, isn't it? Where's this going to
Well,
come
I
in?
can do anything you like, really. Cause
Get you, girl!
well, because I can do...
Are we confident that we can get that first phrase?
Do you think this is about right up there?
No, I don't think it's right. The music's a mess, and there's bad news for the gunpowder.
On our final day, it's raining, the gunpowder's wet, the tubes are wet, so we have to dry everything out. We found a good way of drying the gunpowder is to heat the sand up and then just put the powder on there to dry it. That's a fairly safe way of drying it. We've got the bamboo containers for the Roman candles here. They've got to dry out.
The rain stopped, but the panic started. With only a few hours left before the performance, the orchestra are revolting. What are you doing? That doesn't sound anything like we're supposed to be playing. It sounds like Ode to Joy.
It is. We were really struggling with the last one, Kate. You know, the first 3 notes we could do no problem.
Yeah.
But then the next ones are like a mixture of different notes. They're really hard to play. And
Isn't that what a tune is? A mixture of different notes. Small point, but you know.
You're making our life too difficult.
There's sharps and flats and some complicated chords.
Right.
And this instrument just won't do those. We can, but we don't do them very well. So we thought you'd rather have a nice tune that we can actually play.
That's fine. That sounds fun. I mean, it does sound really good. Sounds really good.
But we need some help. We could really do with this C being played, and it's that long tube there.
That's that one. Yeah.
Okay.
In the face of disaster, the band play on. Will the rocket scientists be able to lift the gloom?
Rocket Mark 1, launch on 3. 1, 2, 3.
Our special launch cam gives a unique view of the test firing.
Oh, well, at least a foot.
Yeah.
It went about a foot, Mike.
I'll get NASA on the phone.
Yeah.
Try again, boys.
Plunge on 3. 1, 2, 3.
I think we want a longer stick. That was the problem, wasn't it? Because it would have gone, but the stick wasn't long enough.
I think it's got more problems than the stick, but time's almost up. The stage is set. We'll have pipes to bang, homemade drums, and the centrepiece, bamboo Roman candles. So here, at last, for one night only, mercifully, enjoy a celebration of rough science.
One, two, three.
And again. 2, 3, go!
of science continues at PBS Online. Point your browser to pbs.org. To order a home video copy of this show on VHS or the entire 10-part series with additional features on DVD, please call 1-800-543-3764.